I'm going to show you a couple examples where you can set up proportions to find missing side lengths in similar triangles. So it says find the value of x, and x is right here at the bottom of the first smaller triangle. And we know that the triangles are similar because it says it right here. Triangle RST is similar to triangle GHJ. So to set up a proportion, I want to find corresponding sides. You could put the x anywhere. It really doesn't matter where you put it. I'm just going to start by putting it on the left and on the top. Since I did that, I need to find its corresponding side in the bigger triangle, which would be the bottom, and that measurement is 9, so that's going to go on the bottom. Now, I set it up so that it's the small triangle over the big triangle. So all the values on the top need to come from the smaller triangle, and all the values on the bottom need to come from the bigger triangle. So when I use another value, it doesn't matter which one, let's just use 10. Okay, 10 needs to come on the top because it's from the smaller triangle. And on the bottom, I need to line it up with its corresponding side in the bigger triangle, which would be HG, which has a measure of 15. Setting up the proportion is the hardest part. Solving it is easy because you can just cross multiply, and you'll find that x is equal to 6. So that side on the bottom of the smaller triangle, RT, is equal to 6. You can set it up big triangle over small triangle, in which case it would look like this. Or you can also decide to use the other numbers, 8 and 12. So if I was going to do big triangle over small triangle, that would be 9 over x. And if I wanted to use the 12, that would need to go on the top because it's from the big triangle. And then the corresponding side with 12 is ST, which has a measure of 8. No matter how you set it up, you're going to end up with the same exact answer, which is 6. Here's another example that's a little bit more difficult because notice how the triangles aren't facing the same direction. They're not in the same perspective, so it's kind of a little bit more difficult to line up the corresponding parts or the corresponding sides that go together. So I'm going to line up my template for a proportion. And x can go anywhere. This time I'm going to stick it on the right and the bottom. Okay, so here's x on the smaller triangle. And the corresponding side from the bigger triangle is on the bottom, which has a measure of 15. Okay. Now, you can really choose what other numbers you want to use. I think I will go ahead, I'm going to change colors, and if I use 12, I know I need to put that on the bottom along with the x because they both come from the smaller triangle. Now, the side that corresponds with 12 is actually 18. Notice how it goes from the 3 tick marks down to the 1, 3 tick marks down to the 1. So it's like this triangle kind of flipped over. So 18 corresponds with 12, and it's from the big triangle, so it needs to go on the top. Once you have it set up, that's the easy part. All you do is cross multiply, and you'll see that x is 10. You could have also set it up small triangle over big triangle, in which case everything would just be flipped. Or you could have chose to use 27, the side right here, and that would need to go, well, in this case, it would need to go on the top, along with the 15 from the big triangle, and then the side that corresponds with that is the 18 from the small triangle. Okay, and then when you cross multiply, you're still going to get 10. So you just need to make sure everything is lined up and goes together in the right way.